How's it going, guys? Today we're going to be going over a problem that I've been discussing with Michael in my Discord server. So Michael, this is for you. Today our problem is called PathSum2, and this is a question that's being asked by Amazon right now. So just as a quick reminder, guys, if you guys ever need help with your interview questions or you guys have any questions for me, you guys are welcome to join my Discord server. The link will be in the description. I also offer other services like mock interviews, on-site preparation, etc., etc. So if you guys are interested, be sure to check the link that is up now or check the links in the description, and I would be happy to help you guys however I can. So our problem today is PathSum2. It's from Amazon, and our problem description says, given a binary tree and a sum, find all root to leaf paths where each path sum equals the given sum. Note, a leaf is a node with no children. So as an example, given the below binary tree and sum equals 22, we would actually want to return this list of lists, so 5, 4, 11, 2, and 5, 8, 4, 9. And the reason for that is if we follow these paths, so 5, 4, 11, 2, that's a root to leaf path, and that sum of all those nodes equals 22. And the same exact thing holds for this path. So what we really want to do here, guys, is we want to traverse the entire tree, and for every single path, we just want to keep track of the sum and actually the list of as well of that path. And with that traversal, by going through all those different paths, we will actually know which of those paths hopefully equal our sum. So this problem isn't too complicated. I think it gets a little bit tricky because we need to make sure that we don't pass the same list around when we keep track of all these different paths. So what I like to do for these kinds of problems, I like to have a shell function that calls a magical recursive function in this case that is actually going to do all of our work. So what we're first going to do is we're just going to write our shell function. And again, our shell function is really just going to declare any variables we need, call a magical function that will do our work, and then return the result. So let's just do that first, and then we'll get into the meat of the problem, which is really going to be a recursive function. So we said we're going to create something that we're going to return, right? So in this case, we need a list of lists, and that list of lists is actually going to represent all the paths that sum to a particular target, right? So we're going to say list of lists of integers. We're going to call this paths because that's what we're looking for, right? We're looking for all the paths equals new array list. And now we said we're going to call some magical recursive function, right? And then we're just going to return whatever we need to populate. So in this case, we're trying to populate our paths. So we're just going to say return paths. And now let's actually create our recursive function, right? So we're going to call something. What does the function need to do? It needs to find the paths. So I think it makes sense to call it find paths. So we're going to say find paths. And what do we need to pass it? We need to pass it the root of the tree that we're on. So we're going to say root. We're going to pass it the sum that we need to sum to. We're going to pass it a list so that we can keep track of what the current path is, right? If we've taken the 5 from the root, or if we're in the right subtree, which might be an 8. So we're going to say new array list of integers. And then the last thing we actually need to pass it is our paths variable, so that every time we find a path that we want, right, a path that sums to our target, we need to add it to that paths array list. So we're going to say paths. So again, this is as simple as it gets for our shell function. We're just going to declare what we need, the work that's going to be done, right, which is in this new recursive function, and then we need to return the result. So now comes the fun part, which is actually creating this recursive function. So we're going to say find paths. It's not going to return anything because it's just going to add to our list of lists that we give it, which is paths. And we're going to say find, whoops, I did this wrong. Sorry, public void find paths. And what did we pass it? We passed it a tree node called root. We passed it an integer called sum. We're passing it a list of integers, right? So list of integers, and this is going to represent our current path, so I'm going to call it current. And then we're also passing it a list of lists of integers called paths. And again, that's just so that when we find that our current path meets our requirement, which is summing to the target that we're given, we want to actually add it to our list of lists, which is called paths. So in our recursive function, we always have two things, right? We always have a base case, so we stop recursing, and we always have our recursive calls, so we continue recursing. So it's always take care of the base case first so that we actually don't get stack overflows. So we're going to say, what is our base case? Well, our base case is when we have no work to do, so that's going to be when our root is null. So if our root is null, I do that every time, we're just going to return. Otherwise, what do we want to do? What we want to do is we want to consider the current node, because now we definitely have one because we haven't triggered this if statement. So we want to consider our current node as being in the path that we're looking for. So we're going to say current, right? So we're adding to our current path, current.add root.val. And now that we've added the current value, what we want to check is, okay, have we gotten what we want? And what do we want? We want paths that sum to a target. And it has to be a leaf node, right? So that's important. So we're going to say now if our if our root.val is equal to our sum, right? So if the root's value is equal to our sum and it's a leaf node, then we've hit the jackpot, we found a valid path. So we also need to check if root.left is null and root.right is null. So that makes sure that it is a leaf node. Then we're going to say paths.add current, right? So we're going to add the current path that we found to our paths variable, or a list of lists that's going to hold all of our paths that are valid. And then we're just going to return. Okay, and so now if we haven't triggered our base case and we haven't found what we're looking for, now we just need to recurse. Okay, so we need to continue traversing the tree looking for the paths that we want. So we're going to say find paths. And now instead of looking at the current node that we're on, we want to start looking at its left subchild, or its left subtree, I should say, which is really on this side for you guys. I always do that. The left subtree and the right subtree. So we're going to say find paths of root.left. And now we're not looking for the current sum anymore, right? We're looking for the sum minus whatever node we're on. So we're going to say sum minus root.val. And then we're going to say current, or actually, this is the important part. We want to say new array list integer current. And so what this is going to do is it's going to make a copy of the current list we have, so we're not passing around the same list. So in every recursive call, we have our own unique list called current. And then we want to also pass our paths again, so that if in that recursive call we find a valid path, we want to add it to our paths. Now we're going to do the exact same thing, so I'm just going to copy and paste, except the only difference is we want to do it for the right subtree instead of the left in this case. So we're going to say root.right. So again, guys, as a quick recap, we have two different things in a recursive call, right? We always want to have a base case, one or multiple, and we always want to have a recursive call. So base case stops us from continuing our recursion, and a recursive calls continue the recursion if we haven't found an answer. So we have our base case, then we check if we have what we want, which is a valid path, and if we don't, we continue our recursion down the tree. So after this whole function returns from this top level call, we will have hopefully populated the paths variable to contain all those paths that sum to our target sum. So let's make sure that this works. Let's submit our code. Awesome, and it does. So guys, that's how to solve path sum 2. Michael, I hope this made sense. I hope this was helpful. Again, if you guys are interested in requesting questions for me to do, check the link in the description. I would love to see more people in the Discord server. If this was helpful, be sure to leave the video a like and subscribe to the channel for more, and I'll see you guys next time.